Okay, 1.5, inverse relations. This is a review from grade 11, inverse relations. So just recall that the inverse of a relation is a reflection in y equals x. So we've done vertical reflections. We know horizontal reflections. Now we're doing diagonal reflections in the line y equals x. So think of this as a line, this orange line over here. If you have a function anywhere, it's just a reflection in that y equals x line. So if you're reflecting it in y equals x, just like when you're reflecting it vertically, the positive numbers turn negative. Well, the y values turn to the x values, and the x values turn to the y values because you're reflecting it in that line. So for instance, if I have a parabola over here, if you think of this like a mirror, it gets reflected down here. Okay, if you're not too visual, you can just like pick points on your regular function. For instance, I could pick this point, negative 6, 3. If you reflect it in y equals x, the points just switch. This becomes 3, negative 6. So you could pick a bunch of points and just flip x and y, and you have your inverse function graphically, right? Graphically. Notice that the domain and range also swap for the inverse, obviously. So if you have all these x values that then become the y values, obviously your domain becomes your range. And if you have all these y values that then become your x values, vice versa happens, okay? So just keep in mind about that right here. So if you have a table, a lot of guys like to make a table when they're graphing. You shouldn't, but it might be useful if you have to graph the inverse, if you don't know how to do it in another way. If this is your original function table, a bunch of points, just like this parabola up there, your inverse function would be swapping the points. So this is 0, 0, this is 1, 1. You won't see an inverse there, but now I go to 4, 2, and 9, 3. So notice that these points all swap x with y and y with x. Really, really easy. So you can graph these, see the parabola, and then you just graph these and see the inverse. Okay, we don't like doing tables, we don't like doing graphically because it's not always available to us. But if it is, you can move much faster if you know how to do it graphically. It's a little visual. Algebraically, when you're finding the inverse, it's very easy if you're good with moving things over to one side, standard, low-level algebra. The trick comes with parabolas that are not in vertex form. This is in vertex form, actually. The h value or the v value is 0. So just take a note that the parabola must be in vertex form. If it's in standard form, you either have to complete the square or use negative b over 2a to find your vertex somehow and just put it in vertex form. Okay? Because you can't solve for x unless there's only one of them. And vertex form is the only way that there's one of them for parabola. Okay, find the inverse algebraically. Step 1, same as last year. We turn f at x into y. And if I'm telling you it's a reflection in x equals y or y equals x, then I can flip or swap y with x. So all I did was switch the x letter with the y letter. And now what I'm going to do is I'm going to solve for the y. So I'm going to bring this 3 over, and it's going to be positive 3. I'm going to divide by 2 and cancel this out. And then I got to find the square root to get to y. Okay, but be careful here because you should know from grade 10, hopefully, that anytime you're finding the square root, you must have plus and minus. You have to. Okay, very, very important. And I'm done here. This is my inverse relation. Okay, so right here I'm going to graph both. Okay. If you don't know how to graph this, that shouldn't be an issue because you should know how to graph that. And if you know how to graph a parabola, just pick some points, reflect it, you're good, right? And especially if you understand the step pattern, you just have to do like 1 point and then you can just apply the step pattern. So my first one is a parabola that's shifted down 3 and stretched by 2. So I'm starting at the negative 3, going over 1 up 2, over 1 up 6. And I don't need more points than that. That would be crazy. I know you can't really see them, but there is my parabola. I missed that point. Okay, so again, I'm shifted down 3, so my vertex is there. And I have a vertical stretch of 2, so my step pattern goes from 1, 3, 5 to 2, 6, 10. So I go over 1, not up 1, up 2. Over 1, not up 3, up 6. And then I don't want to go up 10 because that's off my chart. 2 points is plenty. Now, if you know what these points are, this point is 1, negative 1. This point is negative 1, negative 1. This point is 2, 5. This point is negative 2, 5. And this one, 0, negative 3. We'll go in orange. I'm just going to plot the inverse of all those points, because maybe this confuses me, even though it shouldn't. The k value is a 1 over 2 over here. Right? I can factor out that 1 over 2. I'll write it a little bit better. This means the same thing. This is just a root function, horizontally stretched by 2 and shifted 3 to this way, to the left. Okay? So what about that plus minus? Yeah, two functions have to exist. You'll see what happens here. So 0, negative 3, I always plot the vertex first. This is going to be negative 3, 0 right here. Negative 1, this is going to be the same point. 1, negative 1 is going to be negative 1, 1 up here. Right? And now I already see my step pattern. I see my sideways parabola. So now I'm going to go up 1 over 6 because it's faster for me to do that than to look at a number and switch them. Up 1 over 6, done. Mirror image, finished. Okay, so there's my inverse function. I did not graph it using this, even though I could have. Okay, and you can notice that it looks like a root function over this way and stretched horizontally, right? It's a little less steep. Both exist because this is root x and this is negative root x. Root x is up here and negative root x is reflected vertically. Okay? And both are existing at the same time. And every single time you have a relation that has plus minus, you know for sure you're not going to have a function. Okay? This does not pass the vertical line test. Okay? The inverse of all parabolas are never functions because you're turning that parabola sideways and it's not going to pass that vertical line test. Okay, so is the inverse a function? No, because I just explained it. Okay, two functions are existing over here. One of them is this one, and one of them is this one. Done, very easy.